to the Data Science Interview Podcast. In this channel, we help you dig into topics that are commonly asked about in data science interviews. In today's episode, we'll be discussing a topic that is useful to understand as a machine learning practitioner, and that is regularization. But before we dive into the details, let's start by defining regularization and explaining why it's so important. So, regularization is a technique that's used to prevent overfitting in machine learning models. And if you haven't heard of overfitting before, go ahead and hop on over to our previous episode, to episode 1 of our podcast, where we discuss overfitting and the bias-variance tradeoff. Okay, so jumping right into it, recall that overfitting occurs when a model is too complex and is able to fit the training data almost perfectly, but performs poorly on unseen data. So overfitting means that the model will do well on training data, but it's probably going to fail to generalize on validation data sets. Now, this can be hugely problematic since our goal in machine learning is to create models that give reasonable predictions on unseen data, right? If we already know the answers, we don't really need a prediction. So regularization helps us to solve problems of overfitting or address problems of overfitting by reducing the complexity in a model so that it can hopefully generalize to data that it hasn't encountered before. One way to think about regularization is like that it kind of introduces a penalty for having too many parameters in a model. So basically, regularization is going to help us to constrain our model, which prevents it from becoming too complex. The regularization term is added as an additional component to the loss function. Okay, so there are many ways to implement regularization, but some common methods include the L1 and L2 regularization. And let's go into more detail on these two techniques. So the L1 regularization is used in lasso regression. It works by adding a penalty which is equal to the absolute value of the magnitude of the weight or coefficient. So that sounds a little bit wordy. Let's say that in other words. The L1 regularization, used, let's say, in lasso regression, adds a penalty term to the loss function based on the absolute values of the model's parameters. So I'll repeat that again. The L1 regularization is going to add a penalty term to the loss function based on the absolute values of the model's parameters. This type of approach can be useful when we have something like high dimensional data and perhaps we want to do some feature selection because something like a lasso regression is going to return a sparse solution. So that is, the lasso regression can actually shrink some feature coefficients to 0, which can be very useful for feature selection. All right, and let's move on to L2 regularization. The L2 regularization is implemented in ridge regression, and the ridge regression works by adding a penalty, which is the squared values of the model's parameters to the loss function. So I'll repeat that again. The ridge regression works by adding a penalty, which is the squared values of the model's parameters to the loss function. So again, the penalty term in ridge regression is the squared magnitude of the coefficients. Okay, so how do we decide which regularization method to use and what value to use for the regularization hyperparameter? Unfortunately, there's not a silver bullet answer to this question. Generally, it depends on the specific problem set that you're trying to solve and sort of the unique characteristics of your data set. The rule of thumb is that it can be good to try out different regularization methods and just see which one works the best on your validation set. Okay, so that's our high-level overview into the topic of regularization. Of course, there's a lot more that can be covered in this area as we've only touched upon just the surface, but make sure you keep tuning in with us so that we can dig into other approaches and go deeper in the future. To wrap up our understanding of regularization, let's just summarize some of the key points. We've learned that it's a really useful tool that can help us to create more robust and generalizable machine learning models. We learned about the L1 and L2 regularization. And I hope that you take away from this that regularization is an important technique for addressing issues of overfitting. Okay, so thanks for tuning in to today's episode of the Data Science Interview Podcast. We hope you found this episode on regularization helpful and informative. Be sure to join us next episode where we will be discussing other interesting topics in the field of data science.